Hello students, welcome to my class again. Today I will continue chapter 10. So in the last class we have done up to theorem 10.7. Now I will start exercise 10.4. And in earlier class, in last class, I have given two homeworks from this exercise 10.4. Hope you have done. Now question number 4. If a line intersect two concentric circles, that is circles with same diameter, with center O at A, B, C and D, prove that AB is equal to CD. So here you have to draw two concentric circles. Suppose this is one pair of concentric circles, and what is your question? A line intersects two concentric circles at A, B, C and D. A, B, C and D. And O is the center of the two concentric circles. Let O be the center of two concentric circles A line segment intersect the circles intersect the circles at A, B, C and D. We have to prove that what? AB is equal to CD. We have to prove that AB is equal to CD. Proof. Here we will consider the theorem of chord and the perpendicular from the center. We need one construction, I think. Construction. M perpendicular to AD is drawn. Now proof. Here we will consider the theorem of chord and the perpendicular from the center to the chord. We know the perpendicular drawn from the center to the chord bisects the chord. Okay. Here since AD is the chord for the larger circle. Here two concentric circles. Out of them, one is larger and one is smaller. Therefore, circle and OM perpendicular to AD. So, if AD is the chord and OM is perpendicular to AD, then we can say that therefore AM is equal to DM. Okay. We have earlier done a theorem regarding chord and perpendicular. Again, since BC is the chord for the smaller circle, and OM perpendicular to BC, then we can write therefore BM is equal to CM. Equation number 2. Now, as we have to prove that AB is equal to CD, for that if we subtract 2 from 1, then what we will get? Now 1 minus 2 implies AM minus BM is equal to DM minus CM. Okay? Sorry. Yes. DM minus CM implies AM minus BM is equal to AB and DM minus CM is CD. Hence, we have proved AB is equal to CD. So, this was your question number 4 of exercise 10.4. Now we will go for theorem, another theorem, that is theorem 10.8 of page number 203. What is this theorem? The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. The theorem 10.8, write down. Prove that the angle subtended by an arc the angle subtended by an arc at the center is double the angle subtended by it. At any point on the remaining part of the circle. At any point on the remaining part of the circle. This was to probe. For that, we need one circle having center O. Let O be the center of a circle AOB be the O be the center of a circle, AB be the arc which subtend angle AOB at the center. Okay, this is the angle at the center. P be another point on the remaining part of the circle. And angle APB is an angle subtended by the same arc. AB. This is the symbol of arc. Okay. So P be a point on the remaining part of the circle other than AB, the arc AB, and APB another angle on the circumference. Okay. Now we have to prove that. To prove that, angle AOB is equal to twice of angle APB. We have to prove this one. And to establish the proof, we need one construction. PO is joined and extend it up to E. PO is joined and extend it up to E. Now we are proceeding to proof. In triangle AOP, in triangle AOP, we know a theorem regarding triangle that measure of exterior angle is equal to sum of two remote interior angles. So, in this triangle AOP, angle AOP is the exterior angle and is equal to sum of two remote interior angles, that is OAP and OPA. Just try to understand. Look at the diagram. AOP, angle AOE, AOE, this is the exterior angle, is equal to sum of two remote interior angles, that is angle OAP plus angle OPA. Again, in triangle, come in this triangle in triangle, what is the name of the triangle? BOP. In triangle BOP, what is the name of the exterior angle? BOE, this angle BOE is equal to angle OBP plus angle OPB. This is equation number 2. I am showing here separately. Suppose this is a triangle ABC and ACD is the exterior angle. So, measure of exterior angle ACD is equal to sum of two remote interior angles, that is ACB plus ABC. When you have done the chapter of triangle, in that time you have completed this theorem. So, this is equation number 1 and 2. Now, again, in triangle AOP, again I am considering this triangle. Since we have OA is equal to OP. What is the reason behind this? These two sides are equal since radii of same circle so if these two triangles, these two sides are equal, then you can say that therefore implies OAP is equal to angle OPA. This is equation number 3. Similarly, in triangle BOP, OB is equal to OP. Therefore, angle OBP is equal to angle OPB. This is equation number 4. Now you see, if we put AOP and if we put in place of OPA, if we put OAP, and in place of OBP, if we put OPB, like this, what will happen? You see. Now from 1, angle AOE is equal to angle OAP plus angle OPA. Implies in place of OPA, I will keep OPA same. Angle AOE is equal to angle OPA plus angle OPA. From here I got from equation number 3. OPA and AOP are same. So in place of OAP, I have written OPA. From 3 implies angle AOE is equal to angle twice angle OPA. This is equation number 5. Now from 2, I am writing equation number 2 again. BOE is equal to angle OBP plus angle OPB. These two I have copied again. Here I have to change. So keeping this angle 2 times. Angle BOE is equal to angle OPB. OPB plus angle OPB. From here? From equation number 4. So you can write here from 4. So add these two angles. BOE is equal to twice angle OPB. This is equation number 6. Now if you add 5 and 6, then you will get your result. Adding 5 and 6, we get, what we get? Left side plus left side. AOE AOE plus angle BOE is equal to twice angle OPA plus twice angle OPB. Okay. Now AOE plus BOE, you see AOE plus BOE, this side use 2 times, forget it. What do you mean? AOB is equal to, take 2 common, so angle AOB is equal to 2 angle OPA plus OPB. This side use 2 times, forget it. What remain? APB. Angle APB. So you got your result. Hence, the center angle is double of circumangle. Probe. This was your theorem 10.8. Now theorem 10.9. What is your theorem? 10.9. Angles in the same segment of a circle are equal. This is an important theorem. 10.8 and 10.9 very important to mark on your book. So this I have no doubt in theorem 10.9. I think you have no doubt. So now theorem 10.9. Prove that angles in the same segment of a circle are equal. Write down theorem 10.9. Prove that angles on the same segment, angles on the same segment of a circle or arc of a circle are equal. So for that, again we have to draw a circle. And then a segment to be considered, AB. Let AB be the segment or arc of a circle with center O. Let AB be the segment or arc, whatever the question will be. If the question is segment, in question you find segment, then you will write segment, or if there is arc, then you will write arc of a circle with center O. Angle ACB and angle ADB. C and D are 2 points. Okay. You see, angle ACB and angle ADB are 2 angles standing on the same segment. Or arc AB. Okay, we have to prove that angle ACB is equal to angle ADB. For that we need one construction. OA and OB are joined. OA and OB are joined. If we join OA and OB, what we get? Forming central angle AOB. We got one central angle AOB. Now, to prove this theorem, we will use the help of previous theorem, that is 10.8. Proof. Since we know the angle subtended by an arc or segment at the center is double the angle subtended at the circumference. This is the previous theorem, theorem 10.8. We have written as we know. So, angle subtended by an arc at the center is double the angle subtended at the circumference. Okay. So, this angle AOB is equal to angle ACB. We can say that. Therefore, angle AOB is equal to twice of angle ACB, equation number 1, and angle AOB is equal to twice of angle ADB. AOB is the central angle and ACB is the circumangle standing on the same arc AB. Similarly, AOB is the central angle and ADB is the circumangle standing on the same arc or segment AB. So we can say that AOB is equal to twice of ACB as well as AOB is equal to twice of ADB. Now, if we compare equation number 1 and 2, what we will get? In left side, both the terms are same, so we can say that left side same, so we can say that right sides equal. Since left sides are same, so we can say that right sides are equal. So, comparing 1 and 2, we get, what will get? Angle, twice angle ACB to angle ACB is equal to twice angle ADB. Now from both sides 2 will get cancelled, therefore angle ACB is equal to angle ADB. That was to prove and we have proved. This was all about theorem 10.9. Now, theorem 10.10 is not so important, and if you try at home, I think you will able to complete. Now about cyclic quadrilateral. Page number 205, cyclic quadrilateral. So, first of all, you have to know the definition of cyclic quadrilateral. So, look at the book. Here, one definition is there. Give an idea about cyclic quadrilateral. What is cyclic quadrilateral? Cyclic quadrilateral is that quadrilateral whose all the vertices lie on the circle. Okay. This is called a cyclic quadrilateral. A quadrilateral whose vertices lie in the circle is called cyclic quadrilateral. So, write the definition of cyclic quadrilateral. If the vertices of a quadrilateral lies on the circumference of a circle, then the quadrilateral is called cyclic quadrilateral. The opposite angles of a cyclic quadrilateral are supplementary. There is a theorem we have to prove that the opposite angles of a cyclic quadrilateral are supplementary. Write down the definition of cyclic quadrilateral. So, if the vertices of a quadrilateral if the vertices of a quadrilateral lie on the circle, then the quadrilateral is known as cyclic quadrilateral. Let us draw a cyclic quadrilateral. Suppose ABCD is a quadrilateral whose vertices lie on the circle. You see, this is your cyclic quadrilateral. Now theorem 10.11, 10.10. No, 10.11. Prove that the sum of the pair of opposite angles of a cyclic quadrilateral is 180 degree. In book, the theorem is written as it is. We can write the theorem like this also. Prove that opposite angles of a cyclic quadrilateral is supplementary. This may be the alternate of the above statement. So here we need one cyclic quadrilateral and we have to prove that opposite angles of the cyclic quadrilateral is supplementary. It is sum of the opposite angles of the cyclic quadrilateral is 180 degree. Let A, B, C, D be a cyclic quadrilateral. Let ABCD be the cyclic quadrilateral whose pair of opposite angles are angle ABC, angle ADC, and angle BAD, angle BCD. To prove that angle ABC plus angle ADC is equal to 180 degree, or angle BAD plus angle BCD is equal to 180 degree. This either of these two lines we have to prove. Construction, for that we need one construction. OA and OC are joined. We have joined OA and OC, forming central angle AOC. Now we are proceeding for proof. Since angle AOC and ABC standing on the same arc ADC, look at the diagram. Since angle AOC and angle ABC standing on the same arc ADC, therefore what can we write? Therefore angle AOC is equal to twice of angle ABC, implies angle ABC is equal to half of angle AOC. This is equation number 1. Again, we said about angle AOC earlier. Now we will say about reflex angle AOC. Okay? Again, since reflex angle AOC and angle ADC standing on the same arc same arc ABC. Look at the diagram. This is the arc ABC, and reflex angle AOC, that is central angle, and angle ADC. Therefore, reflex angle AOC is equal to twice angle ADC. Implies angle ADC is equal to half into reflex angle AOC. This is equation number 2. Now if we add 1 and 2, what will get? Adding 1 and 2, we get ABC, angle ABC plus angle ADC is equal to half of angle AOC plus half into reflex angle AOC. Now take common half. Angle AOC plus reflex angle AOC. Now you see angle AOC this and reflex angle AOC this. This togetherly became a complete angle. So half into 360 degree. Any angle and its reflect, if you add, then you will get a complete angle. So AOC plus reflex AOC is equal to 360 degree. Is equal, you will get 180 degree. Okay. So therefore, angle ABC plus angle ADC is equal to 180 degree. So here we can conclude. Hence, opposite angles of a cyclic quadrilateral are supplementary. Proved. This is about your theorem 10.11. Now, before to start 10.5, I have an extra theorem for you. Just write down the theorem, which is not in your exercise. Now your theorem is prove that angles in a semicircle is right angle. Prove that angles in a semicircle is a right angle. This is an important theorem. So in the very first day, when we started this exercise, this chapter, I have discussed about semicircle. Semicircle is the diameter of a circle divides it into two parts. Each part is called a semicircle. So here the concept of diameter is very important. Earlier, I have drawn a circle and then divided this circle by a diameter. So let AB be the diameter of a circle with center O, which divides the circle in two semicircles. Angles on the semicircle you are to prove. So angle ACB be the circumangle standing on the diameter AB. To prove that angle SCB is equal to 90 degree, that is a right angle. Now no need of any extra construction, just we will proceed to prove. Since angle AOB and angle ACB are respectively central angle and circumangle, standing on the same arc. Okay, then you can say that angle AOB is equal to twice angle ACB. Here AOB is a angle, that is straight angle, and I am considering here a central angle. Implies angle ACB is equal to half of angle AOB, isn't it? Then implies angle ACB is equal to half into 180 degree. And since straight angle, we can write. So implies angle ACB is equal to 90 degree. Hence, we can conclude that semicircular angle is a right angle. This angle ACB is a semicircular angle standing on the semicircle only. And that was to prove. And this is all about your theorem of exercise 10, that is circle chapter. Now we will do one or two statement. We will try to complete one or two sums from exercise 10.5. Exercise 10.5, look at the book, page number 207, exercise 10.5. Exercise 10.5, here is a figure given 10.36. A, B and C are 3 points on a circle with center O, such that BOC is equal to 30 degree and angle AOB is equal to 60 degree. If D is a point on the circle other than the arc ABC, find ADC. We have to find out the measure of angle ADC. It is simple. We will use the theorem of the central angle and circumangle standing on the same arc. So, as it is given in the book, I am trying to draw the diagram. This was your diagram. So, given angle, according to question, we draw the diagram. What is given in the question? Given BOC is equal to 30 degree. Angle BOC is equal to 30 degree. Angle AOB is equal to 60 degree, AOB is equal to 60 degree, and to find angle ADC. Now to find angle ADC, so we have angle AOB plus angle BOC is equal to angle AOC. Okay, implies what is the measure of AOB? 60 degree plus angle 30 degree is equal to angle AOC, implies angle AOC is equal to 90 degree. AOC is equal to 90 degree. Now since angle AOC and angle ADC are respectively central angle and circumangle, subtended by the arc. What is the name of the arc? ABC. ABC. Therefore, directly we can write, therefore, angle ABC, therefore, angle AOC is equal to twice of angle ADC, implies angle ADC is equal to half of angle AOC, implies angle ADC is equal to half into 90 degree is equal to 45 degree. So this is your answer. Angle AOD is equal to 40 degree. Now, question number 3. In figure 10.37, PQR is equal to 100 degree. It is drawn in the question. PQR is equal to 100 degree, where P, Q and R are the points on the circle with center O. Find O, P, R. So draw the diagram as given in the question, then proceed to solve. Just to follow as I am doing. This is the circle. So given PQR is equal to 100 degree, we have to find out OPR. We are finding OPR. given O is the center of the circle, P, Q, R are the 3 points. On it, angle PQR is equal to 100 degree. To find angle OPR, since angle PQR and reflex angle POR are standing on the same arc PR, that is this PR. Okay, therefore we can write reflex angle POR is equal to twice angle PQR, implies reflex angle POR is equal to 2 into 100 degree, implies reflex angle POR is equal to 200 degree. Okay, as we have to find out OPR, so we will consider about these triangles, OPR triangle. So we got reflex angle POR, that is this angle, and we need this angle. So if reflex of any angle is found out, then the measure of this angle easily can be find out. Therefore angle POR is equal to 360 degree minus 200 degree, implies angle POR is equal to 160 degree. Equation number 1, just give a number. Now in triangle OPR or POR, OP is equal to OR, since radii, these two are radius of the same circle, so we can say that in triangle OPR, OP is equal to OR, so angle OPR is equal to angle ORP, equation number 2. Okay. Now angle sum property of the triangle, angle OPR plus angle ORP plus angle POR is equal to how much? 180 degree. This plus this angle is equal to 180 degree. Sum of three angles of a triangle is 180 degree. Now put the values. POR and OP are same. We have to find out OPR. So keeping the name OPR plus in place of ORP we can write OPR. Okay, plus what is the measure of this angle? 160 degree. is equal to 180 degree. Implies OPR plus OPR is 2 OPR plus 160 degree is equal to 180 degree. Implies twice angle OPR is equal to 180 degree minus 160 degree. Implies angle OPR is equal to, from here we will get 20 degree then by 2. Therefore, angle OPR is equal to 10 degree. This is your answer. Now, the last question of this exercise I will do, and remaining will remain for your homework. Question number 4. You see, in figure 10.38, angle ACB is equal to 69 degree. Sorry, angle ABC is equal to 69 degree. Angle ACB is equal to 31 degree. We have to find out angle BDC. Just look at the diagram given in the page number 208. Figure number 10.38. Given a circle, and in this circle two triangles are drawn. Name given ABC and DBC. Here the measure of two angles are given. ABC is equal to 69 degree and ACB is equal to 31 degree. We have to find out the measure of angle BDC. Just draw the figure from your book. Question number 4. Given a circle, or in this circle two triangles are given. Name of the triangles are ABC and DBC, in which angle ABC is equal to 69 degree. Angle ABC is equal to 69 degree and angle ACB is equal to 31 degree. Angle ACB is equal to 31 degree. We have to find the measure of angle BDC. We have to find out the measure of this angle. Okay. So, according to question, we draw the diagram. Here given angle ABC is equal to 69 degree and angle ACB is equal to 31 degree. We have to find out angle BDC. So, to find out BDC, we have to consider this triangle ABC. In triangle ABC, apply angle sum property. Angle ABC plus angle ACB plus angle BAC is equal to 180 degree. Sum of three angles of a triangle is 180 degree. Put the value of angle ABC 69 degree plus angle ACB 31 degree plus angle BAC is equal to 180 degree. Implies 100 degree plus angle BAC is equal to 180 degree. Implies angle BAC is equal to 80 degree. BAC is equal to 80 degree. Now you use the theorem of angle subtended on the same arc are equal. So since angle BAC and angle BDC are standing on the same arc, BC, this arc, standing on this arc. So we can say that angle BAC is equal to angle BDC. Implies, what is the measure of angle BAC? 80 degree is equal to angle BDC. Therefore, angle BDC is equal to 80 degree. This was your required question. So, I think question number 5 you can do yourself. In figure 10.39, A, B, C and D are 4 points on a circle AC and BD intersect at a point E such that BEC is equal to 130 degree and CED is equal to 20 degree. Find BAC. So you will use the theorem of equiangular, that is angle subtended on the same arc. Angle, just look at the diagram, angle BAC and angle BDC standing on the same arc BC, like this, like as it is question number 4. And from here you will find out the measure of angle BAC and BDC. Okay, for that you have to find out BDC first. So you try to do this question number 5 and 6. Okay, this will serve your purpose. So hope you understood about circles and chapter 10. If you have any doubt, if you have any problem, then you may text me or you may contact through my mobile number. If you don't have my mobile number, so you may note down 8811863255. You call in this my number at 8:30 p.m. 8 p.m. to 10 p.m. or you may call at daytime also when you feel comfort. So this is up to your class, up to your chapter 10 about circle. Have a nice day. Thank you.